Okay, now this is 6-5. And what we're really going to do is learn one equation in 6-5. And as I told you, there's 4 equations that you need to be responsible for in this class. And this is the third one that we've done. The first 2 were when you are working with difference of cubes and sum of cubes. You need to remember that equation. But this one is t divided by a plus t divided by b equals 1. Now, all of these word problems are essentially the same. You have 2 entities doing work. Let's say Sam can mow the yard in a certain amount of time and Jane can mow the yard in a certain amount of time. And they're going to work together, and you're trying to find out how long it takes them if they work together. So, I'm going to use an example, and this is this is problem number 14 in your exercise set on page 395. But it says that Chandra can embroider logos on a team sweatshirt in 6 hours. So it takes Chandra 6 hours. And then Tracy, who it makes clear is a new employee, needs 9 hours to make the same shirt. So they're trying to find out how long will it take if they work together. So the time that you're trying to find is t. So t is time together, which is easy because t is time and together. And so I want you to think t together, t together, t together. Okay? A is the first person, B is the second person or entity. And this will always be 1 for the problems that we do. So I'm just going to fill this in. So I know I'm trying to find t. So t divided by Chandra, who takes 6 hours, plus t divided by Tracy, who takes 9 hours, equals 1. Now, the mathematics behind this is a little complicated to understand, but it's not impossible to understand. Basically, what we're saying is that if it takes Chandra 6 hours to do something, then in 1 hour, she will have 1/6 of it done. In 2 hours, she would have 2/6 of it done. In t hours, she would have t/6 of it done. Okay? And then, same with Tracy, in t hours, she would have t/9 of it done. And we're looking for how long it's going to take for them to get the whole one thing done. That's it. So, after I create the equation, I just solve it like I did the other problems in 6-4. So what's my common denominator between 6 and 9? I know that it's 18, right? So I'm going to multiply 18. I'm going to write this down. My common denominator is 18. I'm going to multiply it by this side. And I'm going to multiply it by this side. So now I have 18t over 6 plus 18t over 9 equals 18. Now I can reduce, this is 3t plus 2t equals 18. So 5t equals 18 divided by 5 divided by 5. T equals 18 over 5 hours, which if you want, you can say is 3.6 hours, or 3 3/5. That's all there is to it. That is all there is to it, I promise. I don't promise. There's more to it. I lied to you. I'm a liar. You'll have to deal with that. I'm sorry. Sometimes we don't know what it takes the different people, but we know what it takes for them to do it together. And so we have to use relationships between how long it takes the different entities to figure out what it takes for them to get it done together. So I'm going to use an example, and this is number 25 in your book on page 396. It's a good little problem. It involves a person named Zeno and a person named Leah. I don't know where Zeno and Leah are from, but wherever they are from, they have cool names, even though in his youth, Zeno probably found it difficult to write his name in cursive. So, it tells me that Zeno takes 3 hours longer to paint a floor than Leah. But together, remember, T is together, it takes them 2. So, knowing what I know, it takes Zeno 3 hours longer to paint a floor. If it took Leah X hours, how long would it take Zeno? Right, 3 plus X, or X plus 3, same thing. And I've got this super cool equation. Okay? And I'm going to fill in what I know. All right? I know that T is 2 hours. Okay? The first person takes 3 plus X. Second person takes X. And then I just solve. So what's my common denominator? I know it needs to have a 3 plus X. I know it needs to have an X. And that's it. So I'm going to multiply that by all of them. So 2 times X times, I'm going to change that to X plus 3 just because it makes more sense to me right now. And this, because of the commutative property of addition, is X plus 3, just the same. 2 times X plus 3 divided by X equals, remember you're going to multiply it over here too. Okay, remember I just changed this to X plus 3, it's the exact same thing. Commutative property of addition, yippee. So now I'm going to cancel out what I can. X plus 3 and X plus 3, see you later. X and X, take it easy. Now I can rewrite it as 2X plus 2 times X plus 3 equals X times X plus 3. Now I do my distribution. 2X plus 2X plus 6 equals X squared plus 3X. Now I add my like terms. Now I want to set it equal to 0, so I'm going to move everything over here. So minus 4X minus 6 minus 4X minus 6. All right? So this is going to be 0 equals X squared minus X minus 6. X is up front. Minus 3 plus 2. So X equals 3 or negative 2. Now, you have to put your thinking cap on and ask yourself, what is reasonable? Either Leah takes 3 hours or negative 2 hours to paint the floor. And I think it would be really weird if someone could do something in negative 2 hours. So Leah takes 3 hours. And if Leah takes 3 hours, Zeno, not 0, Zeno, who takes X plus 3 hours, would take 3 plus 3 hours, which equals 6 hours. That's it. So whenever you're solving these problems, first, consider what you know. You're either going to have what these two entities can do it in, and you're trying to find out what they do it together, or you're going to know what they do it together, and you're trying to find out what these two people do it in, and you'll have some relationship. And so you always want to define one person as X, and then the other person in terms of X. But remember who's who, and then create your equation, fill in your equation with your knowns, find your common denominator, multiply on top, cancel down, solve, 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 and then put your thinking cap on and figure out which one makes sense. And that is 6-5.